Okay, so welcome back. So, so let's pick up on where we left last time. So how do we estimate the errors if the actual value is not given or is unknown? So there are two ways of estimating errors: if the given or if the actual value is not given, or if the actual value is unknown or the accepted value is unknown. So those methods are through calculating the variance and standard deviation, and calculating calculating measurements involving uncertainties. So let's define variance. Let's define first the different terms. So variance measures variability from the average or the mean. So it is calculated by so it is calculated by taking the summation of the squared difference between the measurement and the mean. So then it is divided by the number of measurements. So here is the mathematical representation, mathematical model. So this is the variance, omega squared is variance, and then summation, and then x of I is the measurement of ith number of experimental value, for example x sub 1, x sub 2, x sub 3. So yan. And then x bar is the mean, and then n is the number of observed measurements. So variance is equal to the summation of x of the squared difference between the xi minus the mean divided by all over number of observed measurements. So variance is an indicator of precision. So it measures how far away are the number from the average and how far away from each other are the measurements within a data set. Gaano ba magkakalayo-layo yung kada data, kada measurement mo or kada data point mo from each other. So when the variance is 0, it means that all measurements are identical. So the smaller the variance, so the smaller the variance, the closer are the values to each other. So which means that if we have a small variance, the values or the data set is precise. On the other hand, standard deviation is the square root of variance and is the measure of how diverse or how widely spread are the measurements from their average. So, gaano ba kalayo yung data point mo from the mean of your data set. So, to get the standard deviation, we simply squared the variance. So, ito, di ba, kung makikita mo to, this is itong nasa loob ng radical. This is simply yan. So meaning that standard deviation is the square root of variance. So omega is the symbol for standard deviation. Xi, measurement of the ith experimental value. X bar is the mean, and n is the number of observed measurement. So small standard deviation means that most of the measurements are close to their average, while a large standard deviation means that the measurements are very diverse, or the data point or your measurement is far away from the mean or the average of all the measurements. So mas malayo siya kapag larger ang standard deviation. Ibig sabihin mas malayo yung measurements mo doon sa mean. So thus, standard deviation measures how close are a set of data from probably the most acceptable value, which is the average. So measuring the accuracy of the measurements in a given data set. So while variance is the measure of precision, standard deviation is the measure of accuracy. So in reporting the measurement x of a physical quantity when given a set of data, we use x So this is the final measurement is equivalent to the mean of the data set plus or minus the standard deviation. So where x bar is the mean and omega is the standard deviation. So let us have an example. So we have here a problem which states that the following values were determined in a series of tape measurements of a line. So nag-measure tayo ng isang line and the obtained values are the following. We have 1,000.58 meters. The second value is 1,000.40 meters, then 1,000.38 meters, 1,000.40 meters, and 1,000.46 meters. So we have 5 observed measurements. So we have 5 trials and 5 observed measurements. So determine the following: variance of the measurements, standard deviation of the measurements, and measure of the line. So for this part, for this type of problem wherein we need to solve for the variance and standard deviation, it is we make use of a tabular representation to organize our data. So mas madali nating makita kung paano tayo magko-compute ng mga kailangan nating values if it is in tabular form. So since these are a set of data, yan. So these are the observations individual. So x of 1 is equal to this one, 1,000.58, until x of 5, which is equal to 1,000.46. So the number of observations n is equal to 5 since we have 1, 2, 3, 4, and 5 observations. So we now have to look for the value of the mean, for the value of, so this is x bar. So naputol lang siguro siya. So this is x bar, the same with that. So mean to mean, as well as this one, this is also mean. So to look for the mean, we make use of this equation, summation of x divided by n. So yung x natin are this one. Yan. So these are our measured values. We have 5 measured values. So we need to get the summation of this one and divide it by 5, or we get the average of the measured values of all the observed data. So ayan na. So to get the mean, ayan na. So 1,000.58 plus and so on until 1,000.46 divided by 5. So our mean is 1,000.44. So if we supply it now to our table, we will now have, so huwag nyo munang pansinin ito. So we will now have a mean of 1,000.44. So this is now the most probable value, or this is the value that is closest to the actual value. So therefore, ito yung gagamitin natin mamaya pagsulat natin nung measurement, final measurement. So mean. So to look for the standard deviation, since standard deviation will determine will estimate the errors in our measurement. So to look for the standard deviation, we need to solve for the variance, and we need to look for all these values. So to get to this value, first we subtract the mean from the measured value. So measured value minus the mean, so we get these values. So 1,000.58 minus 1,000.44 is equal to 0.14. 1,000.40 minus 1,000.44 is equal to negative 0.04. And then 1,000.38 minus 1,000.44 is equal to negative 6. And then 1,000.40 minus 1,000.44 is equal to negative 0.04. And then 1,000.46 minus 1,000.44 is equal to 0.02. So to look for the square root, to the squared, ayan. So we just square this value to get the square of the difference between the measured value and the mean. So 0.14 squared is equal to 0.0196. Negative 0.04 squared is equal to 0.0016. 0.06 squared or negative 0.06 squared is equal to 0.0036, and then negative 0.04 squared is equal to 0.0016, and then 0.02 squared is equal to 0.0004 squared. So the summation of these values will be used to look for the value of the variance. So let us now go back to our solution and look how we solve for the variance. So by adding by getting the summation of this one of these values, we will get 0.0268. So divided by the number of observation, which is 5. So the variance is now equal to 0.00536 or 5.36 times 10 raised to negative 3. So this is a very small number. So meaning that our value, that our data set are very close to each other. So precise ang ating measurement. So now, to look for the value of the standard deviation, to determine the accuracy or to estimate the error of our measurement, so we need to solve for the standard deviation. So standard deviation is equivalent to the square root of the variance. So ito, di ba, yung equation ng variance. So para maalis natin yung square dito, we get the square root of the other side of the equation. Yeah. So standard deviation is equal to the square root of 0.0268 divided by 5. So the standard deviation is equal to 0.0732 or 7.32 times 10 raised to negative 2. So itong gagamitin natin, itong decimal points. So now, nakumpleto na natin yung information. So how are we going to write the final answer? So remember that to find the measure, in reporting the measurement for a data set, so we use this format. So our final measure, so our measurement is equal to the mean plus or minus the standard deviation. So going back to our problem, our mean is 1000.44. This is our this is the value closest to the actual value. So 1000.44 plus or minus 0.07. So bakit 0.07 lang linagay natin dito? It is because the errors as well as the uncertainties are expressed in one significant figure. So yan lang, 0.07 lang. So if there is a need to round off the numbers, then you can round it off. So yan. So dito, since ang next value sa 7 is 3, so just retain the value to 0.7. Ayan. Okay, so in our next video, we are going to discuss the uncertainties in measurement. So the next way on how to estimate errors is by calculating measurements together with their uncertainties. Okay, so thank you for watching.